So, dear judges, we are MaMaFund, and we dedicate to finding out the best allocation strategies in 2020 based on the provided dataset, which spans from 2010 to 2019. We divided this challenge into two sub-problems. First, for the demand side, we need to predict the population size in 2020 and calculate the weights of different factors that influence the cancer rate. Second, we need to figure out the distribution of medical facilities, aka the supply side. Combining both sides, we developed three different models of fund allocation. First, the demand side. To predict the population size, the three models on the left were not adopted because they require too many more factors not included in the dataset provided. We finally chose the auto regression model because the Pearson's correlation coefficient of the population change rates between two respective years is statistically high, and we successfully estimated the 2020 population size.
After this, we imported a new dataset containing breast cancer cases by years, age, and sex groups. First, we introduced the entropy weight model to explore the relative importance of different variables to the breast cancer rates. Based on our results here, we find that sex is statistically more important than age. Furthermore, we calculated the weights of specific age and sex groups using the standardized formula here. From these rates, we can make various conclusions. For example, females aged 60 to 80 are statistically more likely to have breast cancer. Therefore, by applying the calculated weights to the predicted 2020 demographic data, we predict the demand for mammography over different states, as the picture presents here.
Second, the supply side. Facility distribution statistics. We fixed the data zero problems and counted the number of facilities in each state. This is a map based on the facility distribution. Now, let's allocate a found. We take the ratio of facility to demand, which represent the density of medical resources. Clearly, the found and resource density are negatively correlated, so we use the inverse of supply-demand ratio to allocate a found. Here's the result. However, the allocation is too even, which won't resolve the unfair distribution of medical resources. Thus, in the second gap-filling model, we put found step by step to the states where the supply-demand ratio are the lowest until the gap is filled. However, this approach is too extreme and biased, and since the amount of founds is not given, we cannot calculate the exact found allocation ratio. Finally, we construct a least square regression model with the best fit line passing through the origin point. We take the states that locate below the best fit line as resource scarce state and allocate founds based on their residuals and above formulas. This is the found allocation resolution we finally get. Compared with the previous methods, we focus on the states with extremely scarce resources such as California and cover all the below average states at the same time. That's all, thank you.
Thank you.